Alrighty, everybody. Looks like I just got the okay to start our planetarium show. So I want to put away our important message on screen and those space trivia questions because now we're going to be heading into the unknown. Ooh. And once again, welcome everybody to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. I just want to let you know that I'm here. I'm going to be your presenter, or also your space pilot, because I want to be flying during this show. And also, just to let you know, everything that you see in purple is going to be one enormous screen, thanks to the help of 6 different projectors hiding throughout our planetarium dome. We've got 2 projectors in the front, 2 in the middle, and 2 at the very top, all surrounding this planetarium dome, just below that purple glow. And just to let you know, folks, the show that we're going to be doing here is different from all the other previous shows that we've done here in the planetarium today. This show is called Tour of the Universe. And with this show, what that means is that this is completely live. You're going to hear my voice for the next 30 minutes, and I'm going to be flying us through space. And pretty much what we're going to be doing is that we're going to be starting off pretty close to Earth, and we're going to zoom all the way out to the very edge of the known universe. Hopefully, by the end of the show, you won't have an existential crisis of where we are in space. But just to let you know, we are very tiny in the grand scheme of things. So just want to preface that. But looks like everyone has seated and everything. So let me just go over some quick house rules just so that we're all on the same page. We have a great experience in the planetarium. There's a few of us here this afternoon. First off, there's no food or drinks allowed inside. So if you manage to bring any snacks or beverages, make sure those are tucked away to the very end of the show. We want to keep the planetarium clean as much as possible. This also does include no feeties on the seatsies because, again, we want to make sure the seats stay nice and clean. So make sure the feet are on the floor and not on the seats. We do appreciate your help, y'all. And also, folks, if you happen to have any 21st century gadgets like cell phones, smartwatches, tablets, anything that produces bright white light or loud sound, now is the perfect time to turn them off, deactivate them, put them away for the next 30 minutes, as these can be very distracting in a very dark environment like our planetarium. Also, to let you know, these bright devices are quite bright, especially when this planetarium goes dark. It's not only distracting for yourself, but for the folks sitting behind you. So we want to be courteous to everyone in the planetarium zone. So thank you for that. And also, folks, please remember to wear your mask above your nose at all times while we're in the planetarium dome. It looks like there's about 80 of us here in the planetarium right now. We're going to be here for 30 minutes. So, again, can't stress that enough. Please wear your mask, y'all. Thank you so much. And, folks, if you do need to exit the planetarium for any reason, you're more than welcome to do so. All we ask is that you exit at the very top of the planetarium. That's where the exits are going to be before, during, and after the show. So, when in doubt, always make your way up the stairs, not down them. And last thing before we get started, folks, this show can be quite immersive thanks to our 70-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy way to ground yourself. All you got to do is close your eyes, take a few big deep breaths, and your brain will remember that you're sitting in a planetarium in San Francisco and not flying through space, at least not more than the usual. Hee hee hee. But with that being said, looks like we're ready to go. Let's get started with our tour of the universe, y'all. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to planet Earth, but we can see the Earth just a little bit below that nice blue sphere. That's where we live. But we're going to be starting off at this really cool human man made contraption known as the International Space Station. We also like to shorten it by calling it the ISS. Now, a lot of people tend to ask me, what exactly is the International Space Station? I hear about it all the time, but what is it? Well, the International Space Station is a research facility that's orbiting around our planet Earth. Pretty much a bunch of countries across planet Earth had a great big meeting and they wanted to figure out uh, how can we conduct science away from our planet in a low gravitational environment, and that's pretty much here at the International Space Station. Now they conduct all sorts of different experiments up here. For example, they want to test out what happens when you try to grow plants in space. Does growing plants in space do they grow differently up here with less gravity? Do they grow the same? What happens when you try to spark a match in space? Does the flame act the same? Does it act differently? So these are just some of the different questions that they'll test here at the International Space Station that they can't do on Earth, or at least um, takes a lot of resources to recreate that environment, at least. And just to let you know, folks, this is the biggest thing we humans have ever put into orbit around our planet Earth. And it looks enormous on our planetarium screen right now, but it's not that big. It's only about the size of an American football field. So if you've never been to an American football game, don't worry. You can also use the whole California Academy of Sciences, the building that we're in right now, from one garden all the way to the other. And also, folks, what's really neat is that the International Space Station is going incredibly fast. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. Hee hee. And also, folks, the International Space Station isn't too far away from our planet Earth. It's only about 225 miles above the surface of our planet. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. And also, just to let you know, folks, this is as far as we put humans into space nowadays because traveling into space gets quite costly quite rapidly. First, you got to get your hand on a rocket ship or build yourself a rocket ship. And then you got to get your hands on a whole bunch of rocket fuel. And I mean a whole lot of rocket fuel. And then once you acquire that, then you have to also count for all the food, the water, and all the air you're going to be breathing up here while you're in space. So the bill gets quite costly quite rapidly. But let's leave our International Space Station. So this is going to be our starting point, and we're going to slowly see it disappear compared to our planet. Looks like we're just above the Pacific Ocean. And before we lose sight of our International Space Station, I want to add a nice orbital path so we can see where it is as it slowly disappears. Alrighty, folks. So it looks like we zoomed so far out. Now we can get a larger picture of where we are. We're on planet Earth. And just to let you know, the space program that I'm using here in the planetarium is something that you can go home and download if you like and try it out and fly through space if you want to. The space program that I'm using here is called OpenSpace Project. Pretty much, you can type in any of your favorite search engines, OpenSpace Project, and you'll be able to download this program. But just to let you know, OpenSpace is not completely finished. It's in its beta phase, which means we may come across a few bugs and glitches. If we do, I'll point them out to you. But this is a very fun program to use. But also, just to let you know, this program uses a whole lot of processing power. So if you have an older computer, I wouldn't recommend downloading it. Maybe if you have a newer computer or a gaming computer, go for it. It's a whole lot of fun. But if you also want to fly through space without having to download anything, no worries. We also have another alternative called NASA's Eyes. Just like your human eyeballs, just type in NASA's Eyes into your favorite search engine, and you can fly through space just like how I am right now. It's a whole lot of fun. But now that we got a good sense of where we are on planet Earth, let's fly on over to our nearest natural neighbor to us in space, the moon. Now, just to let you know, folks, we humans have been to the moon, but that was quite a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon, conduct science, and of course, they had fun as well. They got to play golf up here. That sounds like a lot of fun. And also, it looks like our moon is a little bit dark, but luckily we are inside a planetarium, so I have some special abilities. Let me turn off the nighttime on the moon. Hey, there we go. That looks much more familiar. But again, folks, the last time we sent humans to the moon was 1972, a little more than 50 years ago or so. Now, just to let you know, NASA has a new space mission in the works that's planning to send humans back to the moon in the next few years. This new space mission is called Artemis. And that's pretty funny to say because Artemis is the sister to Apollo in Greek mythology. NASA is very clever at coming up with these space mission names. But what's the whole purpose of Artemis? Well, they're going to be sending they want to send humans to Mars, but before we send humans deep into our solar system, we need to figure out how exactly we're going to live out here in space. So the moon is a perfect stepping stone to figure out all those logistics. Uh, so pretty much what Artemis is going to be doing, this new space mission, they're going to be setting up different lunar bases across our moon. So maybe they want to check out this large crater. Maybe they'll set up a lunar base just on the outside of it. Maybe they want to go check out the highlands, the mountain ranges over here at the very top left. Maybe they'll set up a base there. Or maybe they want to check out the Maria, this nice flat area surface, relatively newer surface. And what's also really neat is that they're also going to have a space station called Lunar Gateway that's going to be orbiting around the moon at all times. And just in case if anything was to go wrong on the surface of the moon, these astronauts can launch off the surface and head to that space station where they would be safe. And what's also really neat is that Artemis is going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon as well. So pretty cool stuff. So look out for any news about Artemis in the next few years. Crossing my fingers, hopefully everything goes according to plan and nothing gets delayed. Yay! And folks, when we look at the moon here from Earth, the moon sometimes feels incredibly close to us, especially when it's close to the horizon. Sometimes it feels so close you can reach out your arms and touch it. But the moon is incredibly far away from us here on Earth. It's roughly about 240,000 miles away from our planet Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop, going about 80 miles per hour or so. I wouldn't recommend it. The roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities. So astronomers use a more convenient measurement known as light speed. Now, light travels at a mind boggling speed of 187,000 miles per second. That's roughly 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it is time for us to leave the moon. So everybody say bye bye, moon. We'll see you later. And now, folks, we're going to be heading out to a much larger realm of our solar system because now we're going to see the moon and the Earth in their orbits as they slowly disappear. In fact, before we lose track of our moon and the Earth, let's put up some nice trails so we can see where everything is in space. There we go. So again, we're going to start to see those slowly disappear. And on our journey, folks, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace, showing us the most accurate information and images available to us. And now, the nearest star to us, the sun, comes into view. Do, 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 do. And the sun's roughly about 93 million miles away from the Earth. Whew, 93 million miles away. That is incredibly far. But in terms of speed of light, that's not far at all. So again, we're the third rock from the sun, right over here. The sun's right over here, 93 million miles away from us and the sun. And it only takes light 8.5 minutes at the speed of light to cross that distance. So incredibly fast. Now, this is a really cool concept to keep in mind because let's say the sun was to turn off all of a sudden, it's not producing any more sunlight. Just for an example, that last bit of sunlight would leave the sun. It will travel that 93 million miles, travel that 8.5 minutes at the speed of light, and then all of a sudden the daytime on Earth would become nighttime. Now, that's a really cool concept to keep in mind because this works for really far away objects as well. For example, let's say we're looking at a star that's 60 light years away from us. We're seeing that star as it looked like 60 years ago because that light just got to us. It traveled that long distance to get to our eyes. So when we look at a really far away object in space, it's kind of like looking back in time in a sense. Pretty cool. But now that we have a nice bird's eye perspective of our solar system, let's name all the objects in our solar system just to get a sense of what's in it. So of course, right in the middle is our star, the sun. And the closest planet to the sun is going to be Mercury. Then we have Venus, then Earth, that's us. And then we have Mars. These are the rocky terrestrial planets. These are places we can land a spacecraft on. And then beyond the inner planets, these rocky terrestrial ones, we have this really cool thing called the main asteroid belts. And this is what it would look like if we were to highlight all the asteroids in our asteroid belt. There we go. There's quite a few of them in there. Now, what's also really neat is that the asteroid belt was discovered in the early 1800s by a European group of astronomers. They call themselves the Celestial Police, which kind of sounds like something out of Doctor Who, in my opinion. And then beyond the orbit of our main asteroid belt, we have the really big planets. We have our gas giants, the Jovians. We've got Jupiter, Saturn, and then we have our icy gas giants, Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto for you. It just appeared on screen on the left-hand side. There it is. And a lot of people tend to ask me, hey, Christian, why did Pluto get kicked out of the Planet Club? I love that planet. I learned about it as a planet. Whatever happened to Pluto? Well, you see, folks, in 2006, astronomers got really good at about learning about the outer part of our solar system, specifically this region past the orbit of Neptune. This region is called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, the Kuiper Belt's going to be all this stuff. Give it a second. There we go. So this is the Kuiper Belt. Pretty much this is a second asteroid belt way out here past the orbit of Neptune. And mostly what you're going to find out here are icy asteroids and short period comets that don't go too far away from the sun. So again, these astronomers found all this stuff, more than 400 objects out here in this outer part, or this outer region, and they couldn't call all this stuff planets. There was just way too many of them. So all the astronomers and scientists came together, had a great big meeting on Earth. They had to figure out what exactly you need to be considered a planet. And one of the things is that you need to be so big and so massive that you push all the other stuff out of your way. And unfortunately for Pluto, it didn't pass that test because it kind of orbits its own moon Charon, so it kind of gets pushed around. So this is one of the reasons why Pluto got kicked out of the Planet Club and is now considered a dwarf planet. But don't worry, there's quite a few dwarf planets out here. We have Makemake, Haumea, and Aries. And not only that, we also have Ceres in the main asteroid belt. So it's kind of like Pluto said, hey, you kicked me out of your club. I'm going to start my own club, the dwarf planets. But let me put away the Kuiper Belt because that's just a whole lot to look at. There we go. And now, folks, I'm going to be adding on screen some of the different spacecrafts that we sent out in the 1970s to explore our solar system. And there we go. So here are the space trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that nice interaction right over here. And all of these things are traveling fast enough to escape the sun's gravity and leave our solar system behind. But just to let you know, the farthest of these traveling spacecrafts, Voyager 1, has not traveled as far as light travels in a single day. In order for light to travel all the way out to the orbit of Pluto, it takes light about 5 hours. So again, 8.5 minutes to get to Earth, and 5 hours to get all the way out to the orbit of Pluto. But let's leave our planetary system behind because now, folks, we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us over 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And if my calculations are correct, Alpha Centauri is going to be the star system on the bottom right-hand side of the screen. You can kind of see it kind of close to us. So again, 4 years at the speed of light for going from our star system all the way over there. But that doesn't really put into perspective of how long it would take for us humans to travel there. Well, if we were to get in a rocket ship today and left Earth and we made our way over to the next star system, it's going to take us 8,500 years to get all the way over there. Whew, and that's just a one-way trip. But let's stop and consider whether humanity has made its presence known beyond our solar system, because now, folks, we're going to be stepping inside something called the radiosphere. Whoa. So again, we are now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted or rather leaked into space. And it extends about 90 light years, emitting out from the Earth in all directions. And this first began in the early 1930s with strong radio waves, early television, radar signals, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. Now, if you were here earlier and watched our show Living Worlds, this is what we would call the technosignature. And just to let you know, folks, we humans were broadcasting well before that early 1930s. But the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they travel at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is expanding at the rate of 1 light year per year. So is anybody out there listening? And folks, now I'm going to be adding these markers onto the screen. These markers represent some of the many thousands of stars astronomers have discovered over the last 22 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than closely to 5,000 exoplanets just in the nearby vicinity to us. And that number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. So that 5,000 number is going to be going up. But to answer the question, if there's any of them that are Earth-like with conditions suitable for life as we know it, well, we can't answer that question quite yet. We have new space instruments that are being developed right now, so it's going to be another few years before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we're inside our radiosphere. We find an alien civilization somewhere here. Let's say we're on the left-hand side of the screen. We find an alien civilization all the way on the other side. We shoot them a text message. Takes 60 years to get to them. They listen in, answer back. They say hi. Another 60 years. That is a 120-year conversation in the making. Whew, and I can barely wait for a text message from my friend. But of course, folks, planetary systems beyond our radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I'm going to put away our exoplanet markers. And I want to leave our radiosphere up on screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. So let's see how it compares to the Milky Way that we live in. Alrighty, can anybody see their house from here? Just kidding. Alrighty, folks, we are now looking down on our Milky Way galaxy, and our Milky Way galaxy is incredibly large. If you wanted to cross our galaxy from one side to the other, it's going to take you about 130,000 years to cross that distance. Whew. And not only that, our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within this small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave the Milky Way, I do want to stress the shape of it. When we look at the Milky Way from a sideways perspective, you'll notice that we live in a flat spiral disk. Now, this is going to come important later on the show because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south instead of looking through the plane of the Milky Way, which has gas, debris, nebula, planets, stars, black holes, things that obscure their view of the universe. So keep that in mind. We like to point our telescopes galactically north and galactically south. But folks, the Milky Way galaxy is only one of many, many galaxies that comprise the known universe. And in this giant leap, we're now going to see a view where each point of light no longer represents the location of a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local galaxy group, which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And folks, we've zoomed so far back now that we can now see that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other and leave very few galaxies or voids. So we can see a nice galaxy cluster on the left right over here. We can see a galaxy on the very top right, and we can see very few galaxies or voids on the right side of our screen. So you can kind of think of galaxies like people. They like to hang out together in groups, or they like to avoid each other. But folks, we've zoomed so far back now that we are looking at a picture that represents the 30,000 closest galaxies to us in space over 300 million light years across. We got to give thanks to a pretty amazing fellow by the name of Dr. Brent Tolley, an astronomer who worked at the University of Hawaii, who compiled this amazing representation with the work of dozens of other astronomers alongside him over decades of time. So big shout out to Dr. Brent Tolley. I love flying through this galactic map. Lots of fun. But now, folks, we now have automated systems that are mapping even the most distant galaxies. So now we're about to see the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing is not a star. That's an individual galaxy. Whoa. You said it. And just to let you know, the universe is not shaped like a bow tie or a butterfly. Remember when I told you that we live in a flat spiral disk of our Milky Way galaxy? So astronomers like to point their telescopes galactically north and galactically south. If we were to line up our Milky Way galaxy, it would line up just like so, where this purple survey is. And pretty much astronomers still wanted to make sure that there was galaxies through the plane of the Milky Way. So there's that nice purple surveys of galaxies right there. You can see that we found some, but it doesn't go as far and we don't find as many. Pretty much we had to wait for our technology to advance before we can fill in all these dark gaps that haven't been mapped out yet. So it's just a matter of time. We just got to wait for that technology. But folks, it looks like we're running close out of time on our 30-minute journey of our solar or of our universe. There's just not enough time in 30 minutes to talk about the universe. Whew. But let's press on because we still have a little ways to go. And now we're going to be coming across these objects known as the quasars. Now, the quasars are going to be these orange dots at the very edge of the large scale structure of the universe. So there's quasars over here and quasars on the bottom right over here. Pretty much, quasars are short for quasi-stellar radio sources. And these blazing objects are all billions of light years away, so now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's head back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're now about to see the very edge of the known universe. Alrighty, folks. So we've made it to the very edge, and what we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. Now, all evidence indicates that the universe we live in is about 13.8 billion years old. And this is data compiled by Planck and others. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And it's not a typical photo either, but a temperature density image, where the light echoes of the Big Bang are color coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000. But eventually, they gave rise to a large scale structure of the universe, a clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But, folks, we've traveled as far back as the law of physics can physically allow us, so we only have one direction left to go. That's going to be back home. And before we make our nice entry back to planet Earth, let me find a nice entry point through all these quasars and galaxies. There we go. Alrighty, folks. Let's make our way back to planet Earth. So, folks, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back to our Milky Way galaxy. We're heading straight for that radiosphere. And of course, we are making our way downtown, walking fast, faces past, and we're homebound. And it looks like we're approaching our star system now, folks, passing those spacecrafts in the 1970s we sent out to explore our solar system, passing the Kuiper Belt. And we are making our way to the third rock from the sun, our homeworld, planet Earth, the only place humans have ever lived. And it looks like we're about to pass the orbit of our moon, the furthest we've ever sent humans out into space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our tour of the universe. And I want to thank y'all for stopping by and watching with me today. I hope you did enjoy it. But looks like that's it for now, folks. Thanks for stopping by. Take care.